Two students are asked to find the height of a particular building using a barometer. Okay, they're confused, but they got the spirit. Instead of using the barometer as an altitude measuring device, they take it to the roof of the building and drop it off, timing its fall.
The Weather Service reports that barometers are falling sharply. Oh no!
One student reports a fall time of 2 seconds and the other 2.3 seconds. What percentage of difference does the 0.3 seconds make for the estimates of the building's height?
Yeah, no, I don't think they're confused. I think they know how to use a barometer properly.
I think these students are like me before I met you. I'm feeling a kinship.
Yeah. Barometers are meant to measure pressure, by the way. So it would have been a struggle to measure the height of the building with pressure anyway. Doable, but pretty tough.
And I see that the barometer just kind of throws us off. They could have dropped anything to make this claim or prove this. It could have been a basketball, a package of vanilla wafers, but they chose a barometer because we're going to think about air pressure while reading the problem.
Two students are asked to find the height of a particular building using a measuring tape. They decide to drop it off.
It's that number 78.
All right, let's get into this. What do we have? What's known?
So each student recorded a different time when the same item was dropped once.
Yes. So we have building and same building. And for this one, the time it took to fall was 2 seconds. And for this one, the time it took to fall was 2.3 seconds. Correct me if I'm wrong. That seems correct. That seems to be all the information they've given us. But what else can we conclude, given that we know certain things about how things fall?
So we could work gravity into it.
Right. Gravity equals, let's put 9.8 meters per second squared. Do we know anything about the initial vertical velocity?
That would be 0 to start.
Yes. V naught vertical equals 0 meters per second. Perfect. Do you think we can solve for the distance it falls from here? I'll write down our kinematic equations. Number 1, V final equals V initial plus AT. Delta x equals V naught t plus 1/2 AT squared. And delta x can always be replaced with delta y. V final squared equals V initial squared plus 2a delta x. The last one is average velocity.
Would we use number 2, delta x equals initial velocity times time plus 1/2 of acceleration times time squared?
Let's try it. Let's do it for the first one. So we're actually trying to solve for the height it falls, so delta x is just fine here. What is the initial velocity?
The initial velocity is 0.
Perfect. So I won't include that velocity times time. What's the acceleration?
That'll just cancel out.
Exactly.
Then we would have 1/2 times. Will we do negative 9.8 or can we just do 9.8?
We could just do 9.8. We know that it's going to be falling down. So if we want, we can consider the down direction to be positive here. And that can work out. Let's go ahead and plug this into our calculators. 1/2 times 9.8 times 2 squared.
For that, I got negative 19.6.
Perfect. 19.6 meters would be the height of the building, according to this person's drop. Now, we have the second one. It's going to be really similar, but instead of the 2 squared, we're going to replace it with 2.3 squared. Let me know what you get for this one.
For this one, I got negative 25.92 meters.
Nice. 25.9 meters. Okay, that was pretty easy. Now, what are they actually asking for?
What percent difference does the 0.3 seconds make for the estimates of the building's height? So we have two different heights here. Could we subtract from each other?
Yeah.
To find that difference?
Absolutely. So we have 25.9 minus 19.6, and we want percent difference. So I'm going to divide this by 19.6.
But you're going to divide it, not subtract?
Well, no, we do both. So we subtract it to get the difference, And to get the percent difference, we divide it by one of the values.
So when I subtracted, I got 6.3.
Perfect.
So then after that step, you want me to divide 6.3 by each one individually, or just one of them in particular?
Just one of them for now. We can say that it's the percent difference from, we'll call this the original height. The 2 seconds could be the original.
When I divided by 19.6, I got 0.3%.
Nice. I got the same thing. So because I got 0.32, I'm going to call that a 32% difference. Because to get a percentage, you multiply 0.32 by 100. And I just misspoke difference and misspelled it. Making sense?
Don't feel bad. These kids dropped a barometer off of a roof.
That's true.
We're all just doing our best.
To be fair, it's probably an easier way of getting the height than it would be to measure the pressure from the ground and at the top of the building. Because the pressure difference wouldn't be that great.
That's true.
So I don't know. Those kids had that was a high IQ move. Assuming that the difference in time of the barometer falling wasn't because the first time it fell, it completely shattered, and the second time they were really dropping pieces of barometer that floated down.
And it's interesting, they dropped the same thing from the same height, and there was a 32% difference.
That's
I'm wondering,
huge difference.
Did one student drop it with his hand held high, and the other person dropped it from the top of the building, but not any higher? I'm wondering if that was the margin for error.
Maybe one kid chucked it down. Let's look what a barometer looks like to see if these kids should have been dropping a barometer at all. So they look like they tend to be glass.
And it's funny, when I was picturing a barometer, I think I was picturing a metronome, like a triangular structure that would tick and talk. So
here's what I'm
we
thinking.
all have a lot to learn.
I'm thinking the first student dropped it off, and the second student went down with a dustpan and gathered the bits and kind of floated these off, and they kind of sprinkled down to the ground and took a lot longer.
Wait a minute. They only came to the building with one barometer. So that's exactly what happened. If there were 2 drops, then the second drop would have just been pieces.
That's what I'm thinking.
Okay. Because when I first read the problem, I thought they dropped one barometer and each student calculated it differently. But I think there were 2 drops.
And barometers are not that cheap. I mean, the cheapest one online I can find is about $13.99. I'm assuming it's not this digital barometer, but even so.
Was it safety reasons? No one's ever been killed by a falling barometer, but if they had dropped a cinder block or a brick, there was more risk involved?
The teacher went to the students and said, "This is my Dalvey barometer. It's something that my dad passed down to me. It's very valuable." And they took it and they chucked it off the roof.
They go to their science teacher, "Can we borrow a barometer for an experiment?" And they drop it off a building.
We need it for a scientific measurement. Oh, man.
Student's so proud of his kids. He comes back with the pieces of barometer left. Thank you.
Well, we got this figured out. All right. Thanks, Matt.